So today, two topics we're going to cover, which the first one is polygenic traits, and for those people that have done the lab on where you made the offspring, you came across polygenic traits when you were talking about eye color, hair color, and skin color. Polygenic traits is defined as any trait that's going to be controlled by more than one gene, and majority of the times you see things. Here is an example of eye color. And if you notice, it has A's, B's, and C's. Each one of the different letters signifies a different gene. There are two copies of each gene, so if you have dark brown in terms of eyes, you see it's got a homozygous state dominant-wise for A, B, and C. On a test or something, you'll be given a scale with a specific phenotype matching maybe one genotype. There are many other genotypes that aren't represented here, but what you look for is the trend. The trend for dark brown is that you see 6 dominant alleles, then you go down to medium brown and you identify that there are 5. So it starts going down by 1 each time until you get all the way down to blue, which is the homozygous recessive state. And from this point, if I had thrown a random genotype at you that was potentially something like big A, big B, big B, little c, this is not represented on the scale over here, so some people will be confused saying, I can't predict what phenotype that is. To make it as simple as possible, textbooks will just count the number of dominants. So this one has 1, 2, 3 dominants, so it will correspond to the scale here that has 3 dominants. It's the Hazel. So Hazel has 1, 2, 3 according to this diagram, so therefore this genotype will also match the Hazel. For this one, it comes out to be a simple tri-hybrid cross. So I'm going to do that on the next example, the next slide. So I'm going to pick 2 phenotypes right here. Let's say that a person that has green eyes is going to mate with a light brown. So I'm going to go back and forth because I won't remember this all at once. So we have big A, little b, big C was the green. And the light brown was big A, big B, big C, big C. So now you do, this is simply a tri-hybrid cross. You'll come out with the gametes. This parent on the left would produce a dominant A, recessive B, dominant C as one variation. Another variation, dominant A, recessive B, recessive C as a second. Then recessive, dominant, recessive. So this parent has 4 combinations. Then this parent also will have 4. I'm going to bypass and go right along the second. Pretend this is the top of the Punnett square, and this is going to be the side now. So the first combination this parent can produce, dominant, recessive, dominant, and finally recessive, dominant. So this is how you would have completed that tri-hybrid. You could fill it in like it was a true tri-hybrid where you would do big A, big B, little b, big C. But technically we're not looking at this full genotype. All I really care about is the number of dominants. So to simplify this, to make it easier for you and a little less confusing, I'll keep that one there, but really all I care about to figure out the phenotypic ratio is the number of dominants. There are 5 in this box. That's really what I care about. In this box, that's all I'm going to do. I'm going to put the number of dominants that you would have combining this gamete with this gamete. So this one would bring 3, this one would bring down 1. So I'm going to put a 4 in that box because I really don't care about the genotype. I'll continue that across the board. This one still has 3, this one has 1, so there's another 4 dominants that would be placed in that square. This one 3, this one has 0. So now that one is only have 3 from this parent. And that's how you'll complete this Punnett square. You'll have less to mess up potentially because you won't have as many letters to confuse yourself. So here is 2 plus another 2, so it's 4. So I'm not going to fill the rest of this in, but you get the idea of what's happening. When this is complete, completed, I then will go back to my scale and find out how many of the ones that had 4 were there. So I knew that I had a lot of light browns already because I had, from the square, I had 1, 2, 3 already that had 4 dominants. So I know my ratio is going to have some light browns. There was one already that had 5 dominants in it, so they potentially, with the cross that I made, could have a medium brown-eyed child. And that's all you do. That's a polygenic. If there are 4 genes, like maybe skin color, eye color, you would have a 4th gene, probably letter D, and then even more combinations of skin color and skin tones. But you do the same thing that you would do with the trihybrid, now you do with 4 genes coming with combinations. So that's an example. If you have more questions about polygenic,